So in this video, we're going to talk about the chemical symbol. We're going to talk about the elements. We're going to talk about atomic numbers. We're going to talk about mass numbers. We're going to talk about charges. So the learning objective of this video is to identify the atoms of the element based on the number of protons in the nucleus, and also able to identify the number of neutrons and electrons that a particular atom contain. Okay. So all atoms, as we said, have some number of protons, neutrons, and electrons. But how can we distinguish between one atom to the next? What is the biggest difference between a sodium atom, or between a sodium atom and a lithium atom, or between an oxygen atom and a nitrogen atom? Like, what is the biggest difference? Okay. Now, atoms, the identity of the atom can be determined by the number of protons within the nucleus. Okay. And so this number is called the element's atomic number. So for example, we're going to look at a very specific atom of lithium. So one atom of lithium. Okay, so this atom of lithium, we could figure out how many protons it has due to what we call the atomic number. All right, so your atomic number oftentimes is notated as this Z here. All right, we could find this atomic number here, all right, at the lower left of the symbol. Now, what does the atomic number tell you? The atomic number tells you the number of protons specifically, okay? And so in this atom of lithium, we have 3 protons. The atomic number of protons for lithium is 3. So how do we figure out this information? Like, where do you go to figure out how many protons an atom has, or what's the atomic number of a particular element? So you'll find this information that's for the atomic number from the periodic table. So all you need is really the periodic table. Now, all periodic tables typically have 2 sets of numbers for each element. So I'm going to kind of zoom into the lithium here, since we were talking about lithium. And so I'm going to highlight the 2 sets of numbers I was talking about. So you usually have a number here and a number here. Now, depending on the periodic table, depends on its placement, but it's generally the same. You're going to have some non-decimal number, this integer here, and then you're going to have this decimal number. Now, it's the non-decimal number which represents your atomic number, all right, which also gives you or describes the number of protons for that element, or for those atoms within that element. Okay, so if you kind of look next door, all right, you have beryllium. So here's the atomic number for beryllium, and we'll talk about this number a little bit later, but this number is oftentimes called atomic weight or average atomic mass, but we'll talk about that later. We're going to focus on this atomic number here. So the atomic number for beryllium tells us that there are 4 protons because the atomic number is 4. Okay, we could look elsewhere. So let's say underneath it, you have magnesium. Here's its atomic number. So it tells us that the atom of magnesium typically has 12 protons. All right, we could go the other side of the periodic table. So if we go to the other side of the periodic table, we have like phosphorus. Its atomic number is 15. So it lets us know there are 15 protons in the atom of phosphorus. All right, we could go lower. We have bismuth. All right, same idea. The atomic number is here, the non-decimal number. All right, and the atomic number is 83. So we could easily conclude that there are 83 protons in the atom of bismuth. All right, so let's kind of go back and talk about the example of lithium that we started earlier. All right, so as we said, that this number here represents the atomic number. All right, so that's your atomic number, and your atomic number represents the number of protons within this atom. All right, so this atom of lithium, we're only describing one atom here in this case. So now this number here, we call it the mass number. All right, what is the mass number? So the chemical symbol, remember I talked about, represents one particular atom. Now this mass number illustrates the mass of this atom. All right, so this atom of lithium has the mass of 9. Now remember from the last video, we talked about the mass of the atom is mostly or almost completely is responsible by the protons and your neutrons that it contains. And we also said that in the last video that a proton and a neutron each have a mass of 1 AMU. So when we're talking about this mass number, it has the units of AMU, atomic mass unit. And so if you see the mass number, it will tell you it actually represents the number of protons plus the number of neutrons combined. So it's the sum of the number of protons and neutrons combined. All right, so you could use the mass number to help you calculate the number of neutrons a particular atom contains. So in this case, when we're looking at lithium here, well, we figured out how many protons it has, all right, by using the atomic number. And we said earlier, okay, in this case for lithium, we know for lithium has 3 protons. All right, well, the mass number, remember, allows, it's basically the sum of your number of protons plus the number of neutrons. Well, if we know there's 3 protons here, in this case, there has to be 6 neutrons. All right, and so once again, I'm just gonna kind of restate this, that your mass number, all right, is basically the sum of your number of protons plus your number of neutrons. So it's kind of like an equation, if you want to say this, okay? And so if you know your number of protons and you know your mass number, you could easily figure out how many neutrons you have. Now, let's just say if we're looking for mass number. Well, if you're given the number of neutrons and the number of protons, if you combine them, then you have your mass number. So now another important aspect of the chemical symbol is what we call the charge. So atoms will either gain or lose electrons in order to react with other atoms to make new substances or to make new bonds. So the charge gives us information how many electrons did the atom either gain or lose. All right, and the charge will often be found in the top right hand corner of the substance. Okay, so like in this scenario here, you don't have a number. Okay, if you don't have a number, then what that means is that the number of electrons is equal to the number of protons. All right, and this what makes a neutral atom. Oftentimes we just call them atoms. All right, and so if you ever hear the term atoms, you could rightfully assume that the charge is neutral. Okay, but what if it's not? All right, so I'm going to give us an example here. So kind of going back to this lithium. So I'm going to put a +1 charge here. What does this mean? All right, well, in terms of charge, your charge is equal to your number of protons minus your number of electrons. Okay, and so here we see that our charge is a +1. All right. Well, we figured out earlier how many protons we have, right? And that stems from your atomic number, which was down here. The atomic number in this case is 3, all right? So we know we have 3 protons, all right? And so now we just got to figure out how many electrons do we have? Well, 3 minus what equals +1? In this case, we have 2 electrons, okay? And so electrons, as I was saying earlier, this charge here helps us to figure out how many electrons we have. And so if you don't see a number, then you could rightfully assume, and you're going to be right 100% of the time, that the number of protons and the number of electrons are exactly the same, like this scenario here. You know, there's just no charge whatsoever. But if you see a charge, then things change. All right, and I'm just kind of give you another example. So let's just say we're talking about this element here. All right, so this atom, particularly, not element, but atom. Elements is a group of the same type of atoms, but an atom is an atom. All right, so we're looking at this atom here, and what we're trying to figure out is your number of protons, your number of neutrons, and your number of electrons. Okay, and so this is what we're going to try to figure out. Okay, so first we could look at the atomic number. Your atomic number is typically on your bottom left. Your atomic number, all right, tells you, so your atomic number tells you your number of protons. So in this case, we have 8 protons. All right, your mass number, all right, which is your top left, tells you the number of protons plus your number of neutrons. Essentially just tells you how much does that atom weigh. All right, and so in this case, in this oxygen, it weighs 16 AMUs. Remember, the mass is 100% responsible by the protons and neutrons, the number of protons and neutrons. We already know that there are 8 protons, all right, and the mass number in this case is 16. So 8 plus what is equals 16, all right, and all you smart people, all right, we know that there are 8 neutrons. So in this case, there's 8 neutrons. Now, last but not least, we need to figure out how many electrons do we have, and that we could use the charge. All right, so here's the charge in this case, all right, and so noting that the charge is a -2. Now, remember, we talked about this a little bit earlier, that your charge is equal to your number of protons minus your number of electrons, okay? So in this case, if your charge is -2, all right, we already know how many protons we have because we figured that out from the first thing, that there are 8 protons. Then the question is 8 minus what is equal to -2, all right? A little bit of algebra, right? We're solving for x, kind of. In this case, 8 minus 10, all right, is equal to -2. So in this case, there are 2 electrons. I mean, not 2 electrons, sorry. There are 10 electrons, all right, in this case here. All right, and so 8 minus 10 will give us that -2 charge. And so here, you notice we found all 3 subatomic particles, all right, from looking at this chemical symbol only. All right.